unpack that for us a little bit?
Yeah. So, a starting point for this is a few years ago, there was a lot of interest in training industry vertical specific models, that finance companies would say, we've got all of this data that no one else has. And we're going to train a finance model on top of GPTs or on top of Llama, and it's going to be so much better. And actually, all of those were worse than the next generation of GPT because the power of intelligence and the ability to synthesize new information was bigger than the power of sort of memorizing the old information that you have. So that's I think what this theme looked like a couple of years ago. But, fast forward a year or 2 years, now the story is I have all of this proprietary data. I've accumulated it over years. And in some sense, for a lot of times, if that data is teaching the model a skill, or if it's meant to teach the model a skill, that data is sort of embodied labor, right? Someone worked through all these case studies. Someone called all of these customers and found out all of this information. Well, that embodied labor is now free. AI can do all those things. And so now there's an opportunity. You can have AI call all those customers, do a big survey, find out what they know. You can have AI work through all the case studies, just a lot of chats with O3, right? And then now you've replicated that proprietary data, but without needing all of that work.
A tangential question to why AI is making so much progress in math. Why has it been so slow at computer use? Which is what computer use is actually very verifiable. It's like, is my Etsy package coming? Or like, is my event booked? Whatever. These are extremely verifiable things to survey. What computer use lacks is grindability. So because websites have like bot detectors, and also it takes a tremendous amount of compute to run parallel rollouts, it's very hard to just run like 1,000 parallel rollouts of the same checkout flow on Amazon because you'll get like shut down by Andy Jassy, right? And so you can
personally presses the like red X on Dwarkesh button.
Exactly. And so you could try to build clones every single website. This is very labor intensive and slows you down. So, and the reason, by the way, you need to do so many parallel rollouts in order to learn a skill currently with deep learning is that we haven't solved sample efficiency.
Sucking supervision through a straw,
yeah,
like
exactly.
Karpathy says.
And of course, people are working on many different techniques, but fundamentally, there's this big problem, and there's this big constraint in the way we train AIs that we just, with code also, you can containerize a given level of progress in a repository, and then just spin out thousands of parallel containers or hundreds of parallel containers and say, like, try to implement this feature. And it's totally deterministic. And because it's deterministic, you can solve the credit assignment problem because you know that whatever caused this rollout to succeed and this one to fail, the diff is the thing that like worked. And this way you solve the credit assignment problem. If you have situations that are starting off at different starting points, this credit assignment problem becomes much harder to solve. But most of the things in the real world are just very hard to containerize in the same way. Like coding and math are exceptions to this rule. But if you're just trying to figure out, how do I build a new business that succeeds? How do I like go trade in the markets for a day and like make money? You can't like, the fact that you had to interact with the real world and like things change day after day means that you can't keep replaying and grinding and farming the simulator. But the math, of course, is the exception. And I feel like this is actually an important driver of progress in this domain and also in coding. It's not just verifiability. It has to be grindable. The third
job is like a basket of tasks, many small components of things that in totality brings meaning to our work. It allows us to achieve our purpose of our work. So for example, a radiologist looks at the images, the scans of maybe ultrasounds or CT or MRIs, but that's the task that they do. And now it's completely AI automated, but their purpose is really to diagnose disease, help patients get well, help them understand their disease better. So the purpose of a job is a collection of tasks, a basket of tasks. Many of those tasks will be automated. And my sense is that as a result of automation, we can focus on the harder parts of our work, and the harder parts of our work is elevated as a result. We can be more ambitious. My guess is that we'll probably be busier. The opposite.
There was a tweet that blew my mind recently, and I keep thinking about it like every other day. It was something along the lines of, you can outsource your thinking, but you can't outsource your understanding. And
I think that's really nicely put.
So, yeah, because I'm still part of the system, and I still have to, somehow information still has to make it into my brain, and I feel like I'm becoming a bottleneck of just even knowing what are we trying to build, why is it worth doing, how do I direct my agents and so on. So I do still think that ultimately something has to direct the thinking and the processing and so on, and that's still kind of fundamentally constrained somehow by understanding.
The case, and when we look within Anthropic, we're hiring more people with lots and lots of experience than we did before, because the returns on intuition are much greater than before, because now you don't do the schlep work to run your experiments.
What do you mean by returns on intuition? It's like expertise.
If you're an experienced researcher and you have a ton of ideas for experiments to run, well, previously we needed to also give you an engineering team so that you and the engineers could run the experiments.
Right.
Now Claude runs the experiments. So actually, let's hire way more people with like senior intuition than we did before, because we don't need to scale these other engineers around them.
So do you worry about a kind of reserve army?
AI has made being a professional software developer harder because it's raised expectations for what we can do. And you can now take on so much more ambitious projects. It used to be we had to stay in our lane. Like I was a back-end Python programmer with a little bit of HTML and JavaScript because I could only skill up to professional levels on one of those technologies at a time. Now, I'm writing, here's a fun thing. Here's a little app I wrote in Swift UI that helps me see what bandwidth my computer is using. And this is another one that shows me what's using my memory and what's using my GPU. I don't know Swift UI. I have no idea what I'm doing. I didn't even have to open Xcode for this thing. Claude Code is like, hey, no Xcode needed. I'll just build this up and stick it in the menu bar for them. I would not recommend other people use or trust this piece of software because I don't know what I'm doing. But it's also, I've been using this software for like 4 months now. I kind of trust it now. Like, I've realized that the thing I care most about isn't that an expert wrote the code. I care that a real human being has actually been using it for longer than like 2 hours. And it's sort of built up that, like, over time, that trust in the software gets built up.
They make a kind of mistake that's very interesting. They're trained on knowledge that we give them, but there's an awful lot of knowledge that's not written down anywhere. So I'll give you an example. I'm in a business meeting and somebody comes up with an idea of doing a rev share. And another person says what we should do is do a joint venture. And I said, confidently in my CEO voice, joint ventures don't work and rev shares don't work. Now, I've never said that publicly. So how would the computer that's impersonating me know that? He would have to go through lots of failures, lots of disasters, lots of problems. Furthermore, these kinds of rules are not written down in business books. So I'm using that as a trivial example. There are thousands and thousands and thousands of pieces of knowledge that you all have in your heads that these things don't know and will not or are unlikely to know.
To your point, the single most important thing for anybody wanting to break into any industry is go to the headquarters or cluster of that industry. Like, move to wherever that thing is. And all the advice of you can do anything from anywhere and everything's remote is all BS. And you see that for every industry, not just tech. If you wanted to get into the movie business, people wouldn't say, hey, you can write a film script from anywhere, you can digitally score it from anywhere, you can edit it from anywhere, you can film it anywhere. Like, go to Dallas and join their burgeoning, film team. They'd say, go to Hollywood. And if you want to do something in finance and you're like, well, you could raise money from anywhere and come up with trading strategies and a hedge fund strategy from anywhere, and you could do it from anywhere. People wouldn't say, hey, go to, whatever, Seattle. They'd be like, go to New York or go to XYZ Financial Center. So the same is true for tech. And Shreya and my team has been performing this sort of unicorn analysis of where is all the private market cap aggregating for technology. And traditionally, about half of it's been the US, and then half of that has been the Bay Area. But with AI, 91% of private technology market cap is the Bay Area. 91% of the entire global set of AI market cap is all in one 10 by 10 area, right? So if you want to do stuff in AI, you should probably be in the Bay Area. Mm-hmm. Probably the secondary place is New York, and then after that, it drops off a cliff. And really, it's the Bay Area.
I think the simplest demonstration of this is an exchange. Like, an exchange is just a software program, but the value is in the coordination that everyone has chosen to trade there. There's the most liquidity there. You get the best prices, either a buyer or a seller. And so it's not the case, like, the hard part of setting up an exchange is not writing the code for the exchange. Mm-hmm. It's convincing everybody to coordinate around yours rather than somebody else's.
Mm-hmm. In many ways, the software was maybe there are a few cases of businesses where they built like tremendously like difficult to produce and test software, but for the most cases, I don't think it ever was the moat.
Okay. Weirdly, the billable hour problem is the same problem that I think the entire world is about to run into. Like the billable hour, for those that don't know what it is, it basically is when you get a bill from a law firm, it says in 6-minute increments what people did, and then the hourly rate or the 6-minute increment for that task, right? Why do they do that? It is because they're trying to show ROI. They're like, hey, your legal bill's $100,000. We're gonna break it down into 6-minute increments, right? This is kind of like the main problem that I think the entire world is about to hit, which is, I just spent $1 billion on tokens. Where's my ROI, right? Mm-hmm. And I actually think that like, there aren't enough companies that I know of that are starting to think about how do I actually show ROI in every single vertical use of these things. And I think that vertical companies are gonna have a huge advantage here, where you can start to get to the point where you basically can show every single token and what the ROI was of that token for your particular task in a vertical.
Obsessively at how this was the most important problem in biology. And more importantly, I think of it as a root node problem. Like if you could unlock that and find the structures of proteins, that would unlock whole new avenues of research. Things like drug discovery, obviously we're trying to push that, but also fundamental biology and disease understanding. So this was a problem worth really spending a lot of attention and time on because of the downstream effects that it would have.
And so forth. But here's the thing that's interesting. In the last 27 years, we calculated somewhere between 20 to 30 million people we didn't call back. We did not call them back because we didn't have the people to do it. So just this week, I called back 50,000 people, just through agents. So I can qualify. I just bought a company called Qualified, so I can qualify the agents, call people back, the BDR, the SDR function. I can go outbound. I can do things I could never do before. That is made possible by this AI automation, linking it then to the apps. You can go to another level.
Yeah. Okay. Breaking news.